Hello everyone, welcome to my channel. I have created this channel to promote the online learning and the knowledge that I have to put it in a good use. So without wasting any time, let's directly jump into the topic. And before doing that, I just wanted to say feel free to provide any kind of feedback that you have regarding my videos into the comment section. So let's start. So today's topic is the number system. Okay, here we have a video index, and in the index we have our topic and what else we are going to discuss in this video. So we have types of numbers and the conversion of decimal to binary and binary to decimal in the practice question. Okay, so what exactly the number systems are? So number system is a mathematical notation for representing numbers of a given set by using digits or the other symbol in a consistent manner. Basically, with the help of number system, you can represent numbers in a different way, or you can use the different forms of the number system to make it more understandable. Let's take an example. Uh, of a decimal number system. If you are writing 1717, you can easily able to crack that code that it is 17, but the 1717 is not exactly the same for the computer, just because computer understand a different number system that is called binary number system. So these all different forms of number systems have their own importance. So let's directly jump into how we figure out the number systems and what all we can do with the number systems. So we can do all kind of mathematical or arithmetical operations like addition, subtraction and division with all other number systems that we have. And just to identify a number system, we can use a digit and its position in the number and the base of the number. So let's move forward. Let's see. Moving forward, we have our decimal number system. Decimal number system has all the values from 0 to 9, in total 10 values. That is why it has its base as 10. Then we have a binary number system. Binary number system understood by computer, and it have only two values, that is 0 and 1. That is why it has its base as 2. Okay. Then moving forward, we have our octal number system and hexadecimal number system. So when we talk about octal number system consists 8 values, that is from 0 to 7, and it has its base as 8. And hexadecimal number system has 16 digits all total, going from 0 to 9, and then every digit represented by some characters, that is A, B, C, D, E and F. Okay, that is why it has its base as 16. So we all know that binary is understood by computers, decimal understood by everyone, and octal and hexadecimal we don't have that much of a background. So let me tell you something interesting here. These are also being understood by our computers only. Okay, and octal decimal number system is used very much in the Linux. If you ever heard about UTF-8, it is a representation of octal number system. And hexadecimal number system is also understood by computers. It is used whenever we have very long binary digits, and or I say binary strings, and we want to represent them in the 4-bit digits. So we use hexadecimal number system to shorten the binary strings. Okay, so here is a table that will tell you the base and use digits and some example of binary, octal and hexadecimal number systems. So let's move forward and see some conversion here. So first example is for decimal to binary, and I have given the steps that how we convert a decimal to binary. So here is an example where we are converting 17 base 10 into a binary number. And if you look into the table, that is very easy and you'll easily able to get it how we do it. So 17 divided by 2. So first question is why we are dividing here the number with the 2. So we always divide it with the number of the base we are converting it into. So we are converting 17, which is having a base 10, into a binary which always has the base as 2. So we are converting it into a binary number. That's why we are dividing it here with the base of the binary number. So let's say 17 divided by 2, the quotient will be 8 and the remainder will be 1. So we'll take the binary value as 1. and I'll tell you what LSB and MSB are in the later. So we keep on dividing it. Then we have our quotient as 8, and we divide that quotient 8 by 2, will have 4, and remainder will be 0. And further on, 4 divided by 2, remainder 0, 2 divided by 2, remainder 0. And when we divide 1 by 2, it will have result as 0 but the remainder as 1, because it is not divisible. So then we'll take the remainders and put it in the binary value, and we always go from most significant bit to least significant bit, that is MSB and LSB. So our result will be 1 0 0 0 1 from bottom to top. Okay, so this is our answer when we talk about it. Okay, 17 base 10 will be equals to 10001 base 2. Okay, so next we have in the queue is a binary to decimal number system. Here are the steps that can help you to convert it, and I'm going to explain it anyway, so no problem. Okay, and there is an example how we will convert our binary number system into a decimal number system. So the question is 1102 with the base 2. We have to convert it into decimal number system, that is base 10. Answer would be 13. You can see it here. So let me show you. That would be more easy for you to get. Okay, so let's say we have our number 1. Okay, let me select it first. Okay, so we have our number 1 1 0 1. So first of all, we start assigning with the base value. So base value is directly from if we'll move from here to here all the way, it keeps on increasing and it starts with 0. The base value for this number would be 0, for this number would be 1, then 2, and then 3. Okay, so base value we've identified, and what we'll do is basically we keep these values as the power of 2. So this would be power of 2 0. Okay, this would be 2 to the power 1, this would be 2 to the power 2, this would be 2 to the power 2 to the power 3. Okay, and then we multiply with the digits they have in them. Okay, so it would be multiplied by 1, this would be multiplied by 0, this would be multiplied by 1, and this will be multiplied by 1 again. Okay, so then we will finally add these values. Okay, so let's say 2 to the power 0 would be 1 into 1 is 1. 2 to the power 1 into 0, anything multiplied by 0 is always 0. Then it's 2 to the power 2, so 2 to the power 2 is 4, multiplied by 1 is 4. 2 to the power 3 is 8, and multiplied by 1 is 8. When we'll add them, okay, the total would be 13. So here is your answer. Okay, so that's how we convert a binary into a decimal number system. As we are done with our example, I have some practice question for you all. If you will practice it, you will get to do it very fast and very easily. So practice is always necessary. So here are some practice question if you'll do it. So you can take the screenshot of this, and we'll meet in our next video. Thanks a lot. Thank you everyone. Bye.